Understanding and using the formatting subsystem. In prior nuggets, I've sort of tempted you with the idea that we'll be able to really control the formatting of Windows PowerShell's output, and this is the nugget where we're going to make it all happen. We're going to start by really analyzing how PowerShell turns all these objects into the text that you see on the screen, and talk about the text that appears in the console window and how that's manipulated. We'll look at the formatting subsystem, specifically 3 commandlets called format wide, format list, and format table. We'll look at some advanced features of format table as well, including the ability to create custom columns with calculated values in the tables that are displayed on the screen. We've already talked briefly about some of the ways that Windows PowerShell uses to convert objects to text. For example, when we run get service, Windows PowerShell is retrieving a whole bunch of service objects, placing them into the pipeline. Under the hood, even though you can't see it, the pipeline always has this out default commandlet at the end. Now earlier we said that out default took those objects and converted them to text for display on the screen. That's all technically true, although it's really an oversimplified version of what actually goes on. Let's take a look. Now we start with some commandlet that's going to produce some objects. Let's use getProcess or PS as an example. Those objects are indeed placed into the pipeline, where they wind up eventually at the end of the pipeline, and that's where the out default commandlet sits. The trick with out default is that it doesn't actually do anything though. In the Windows PowerShell.exe that we're using, that's the blue screen window that we've been typing into, out default is programmed to simply forward objects onto a commandlet called outHost. In PowerShell terminology, the host is the console window. So this is really how the objects wind up getting to the console window, but they kind of have to take a roundabout trip to get there. You see, outHost isn't actually capable of working with normal objects, like services and processes and so forth. It's only capable of working with a certain type of formatting object that Windows PowerShell knows how to produce. So here's what happens. We produce the process objects. They get transferred over to outDefault through the pipeline. outDefault transfers them to outHost. outHost says, hey, are these formatting objects? No, they're not. So I need to pass the objects off to the formatting subsystem. So the objects are sent to the formatting subsystem. The formatting subsystem consumes those process objects and creates a new type of object called a formatting object or a formatting directive. Those are sent back to outHost. That's the type of object it knows how to work with. And so that's how it can construct the little screen we see with whatever output appears. So the objects go from the pipeline to outDefault. They're piped to outHost. outHost can't do anything with them, so it sends them to the formatting subsystem. It produces those formatting objects, sends them back to outHost, and outHost finally displays them on the screen. It's something that's a little bit difficult to see in action because, well, PowerShell makes it easy for us. We just type a command, and it all happens behind the scenes under the hood. But the thing that's really doing all the work there is PowerShell's formatting subsystem. So how does the formatting subsystem work? Amongst other questions, why is it choosing these particular properties to display? How is it converting the virtual memory from a bytes figure into a megabytes figure? When we run get service, why is it choosing these 3 particular columns? Why is it displaying them in a table format? Why are they this width in particular? Well, all of these questions can be answered by simply going to the Windows PowerShell installation folder. See Windows System32, Windows PowerShell version 1. And you'll notice several files that have a .format.ps1xml file name extension. Let's open one of these up in Windows Notepad. And back in the shell here real quick, remember that if we pipe getProcess to getMember, it tells us that the type of object we've got is a system.diagnostics.process. I'm going to hit enter to copy that string to the clipboard, and then come up to your Windows Notepad and ask it to find that string. Okay, it found it, but that's actually a process module, so let's find the next one. and there's a system.diagnostics.process. This is a view, and it's defined in this XML file. The name of the view is process, and it's triggered whenever an object of this type needs to be displayed. When PowerShell needs to display an object of that type, it's going to do so in a table. And the table is going to have the following headers: a handles column that's 7 characters wide, an npmk column that's 7 characters wide, a pmk column that's 8 characters wide, and so forth. And the data that's actually going into those columns is the handle count property, the npm property divided by 1024, the VM property divided by 1048,576. In other words, to make it megabytes, this is dividing it by 1024 to make a bytes property into kilobytes. So that's how all this data is being done. Every time PowerShell has to display an object, it goes to one of those format.ps1 XML files, looks for the type name, chooses the appropriate type of layout, in this case a table, although you'll see others that have a list. For example, this is a PS snap-in info. It's triggered by a system management automation PS snap-in info. I bet I know how to get one of those. Let's try typing get PS snap-in and pipe it to get member. Yep, that's a system.management.automation.ps snap-in info. So if we just run PS snap-in, we get a list that includes the name, PS version, and description. Back in that file, there they are, the name, the PS version, and the description. So it's these format.ps1 XML files that really control how all the formatting is done by default. And I have to emphasize that because those are just the defaults. PowerShell's team tried to come up with defaults that made sense for the type of information that an administrator would most commonly want to look at most of the time. But they also gave us complete control over manipulating this formatting subsystem entirely on our own to get exactly what we want to see, never mind the defaults. And the way we do that, of course, is with the 3 format commands that I described earlier. If we ask for get command for the verb format, see that there's actually 4 formatting commandlets. We'll be working with format list, format table, and format wide. Format custom requires quite a bit of advanced setup, and you really have to be able to create one of those XML files to tell it what to do. So it's a little out of scope for what we're going to cover here. We'll start with format wide, which is the simplest of the 3. Looking at its help, I see that it accepts a property that I want to display, and I can either specify auto size or specify the number of columns I want to see. Let's type get service, pipe it to format wide, which has an alias FW, and let's see what it does by default. I didn't even have to specify a property because by default format wide will look for a property called name. Since the service object has a name, that's what gets displayed. I could specify a different one like display name, and its default is to always display 2 columns. Let's try it again. Let's try it with just name, and we'll ask it to auto size. Now this time it determined that it could fit 3 columns in. I could also force it by specifying call for to try 4 columns, but you'll notice that some of the service names might not fit, and so they'll be finished off with the ... ellipsis. So format wide is good whenever you just need to see one property and you want to see it in a more compact multi-column view. Next up is format list. Really similar, except this time we can specify multiple different properties in a comma-separated list. We don't need to worry about columns or anything like that. We're just going to get a bunch of services, pipe them to format list, and specify that we want to see the status, the display name, and the name. And that's exactly what we get. And that's exactly the order they come out in, too, is the order we put them in: status, display name, and name. What if we wanted to see all of the properties that were available? Well, fortunately, we can put wildcards. Just say star. And that's a little trick that you learned in an earlier nugget. And it's a good way to see every single property for every single object. Now, format list has another cute thing, and actually format wide has this too. Let's go back to the help. And it's this group by. So let's try this. Let's ask for all the services Let's format them in a list. Oh, we could just use an alias FL here. Let's specify the properties that we want to see. We want to see the name and the display name and the status. And we want to group them by the status property. Not exactly what I expected. You see, what it's doing is going through the list in the order in which it got them from getService. And every time it sees a change in the status property, it just creates this new header. The problem is that status property changes throughout the list, so we need to recall that line, and prior to trying to group them, we need to sort them by status first. That way all of the running ones show up first, and then all of the stopped ones, and so the value of the status property will only change those 2 times. This time we see all the running properties at the bottom of the list, and there's a little header right there for the beginning of the running properties. And then the top of the list had the stopped properties, and it also had the little header there. So all of the format commandlets have that group by capability. You just need to know that it's important to sort them on whatever property you plan to group them by. Last up is possibly the most useful of the formatting commandlets, format table. This accepts a few different properties or parameters. One of them is property, and you can specify more than one property. And that's how you control the columns that appear. There's that auto size again. We can have it hide the table headers if we don't want to see those. There's the group by option, and we've got this wrap option as well. So let's take a look at some of the things we can do with this. Let's run getService format table. You know what? We can just use the alias FT. Now that looks pretty familiar. Remember, the default view for getService was already a table, so this isn't going to be any different. So let's specify some different properties here. Let's say that we want to see the name first, and then the status, and that's all we want to see. Here's something interesting about the format table commandlet. By default, it tries to fill the entire width of the screen, and that's why you see all this blank space in the middle. Another option is to specify the auto size parameter. That'll force each column to be just as big as it needs to be in order to fit the data we specified. That can kind of backfire sometimes. For example, let's specify getProcess with format table. This time let's tell it to display all of the different properties. Yeek. It's trying to fit as many as it can, and you'll notice it's actually wrapping the column headers, and even so, 18 of the columns didn't fit onto the display. For the actual display, it's only showing the first character. Not terribly useful. Let's try it again with auto size. Now here's the downside. It actually has to, you saw it pause there for a moment, it had to figure out how wide it needed all these, so it needed to look at all of the processes and kind of spend some time formatting them. So sometimes using auto size can be a little slower. This time 57 columns didn't fit, and even the last one didn't fit all the way. One thing we can do there to help is to allow it to wrap that column instead of trying to fit it all on one line. Now that column was allowed to wrap around, and so we can see all of the data, even though it didn't fit all on one line. So you get lots of options here. Here's another one. Let's get all the services, sort them again on status, format them by table, and let's just keep the display name, and we don't need the status because it's going to show us what that is. Let's see what comes up here. So we started off with just the display name. Oh, we forgot that all-important group by status. And see how easy it is just to pull the command back up and modify it, and now we're getting it grouped by status. All the stopped ones first and all the running ones next. And of course we could pull it back up and modify it again. Maybe we want to pump that out to a file. Services. So the format table commandlet actually gives you a lot of different ways that you can play with the output, configure it, get it to look exactly like what you want. Let's take another example with getProcess. We've got lots of columns there already. Maybe we don't want that. Maybe that's too many. Let's try getting processes, formatting table. So just give me the name, the ID, the virtual memory, and the physical memory. And there we go. And let's make that a little bit neater. We'll recall that and type auto size. And there it is. Or maybe we want to go back and modify this again and sort it on virtual memory first in descending order before we format it. And that's kind of a cool trick you're going to need to learn. The format commandlet always needs to be the last thing on the pipeline. Remember, if we run get process and pipe it to get member, we get a process object. If we run that command we had there with the sort and pipe the output to get member, it's still a process object at the end of that pipeline. But once we put that format in and pipe it to get member, the process objects are gone, and what PowerShell has created are those internal formatting objects that outhost can use to actually create the text display we see. So the format thing needs to be the last thing on the command line. Now, wait a minute, didn't we just a second ago take the results of a format commandlet and pipe them to out file? Well, wait a minute, what's in that file? Let's open that up in Notepad. Did we just get a bunch of formatting nonsense? Oh, no. No, this actually looks really good. Well, the fact is, format commandlets need to be the last thing on the command line unless it's an out commandlet. All of the out commandlets know how to deal with the formatting objects that the formatting commandlets produce. So whether you're going to go out to a file, out to the host, or out to a printer, it's okay to output formatting objects to those. Apart from that one exception, though, the formatting object really does need to be the last thing on the command line. Now, the last cool formatting trick is a cool one indeed, and it still uses the format table commandlet. Let me start by running getWMyObject to retrieve the Win32 logical disk class from my local computer. I've got 3 logical disks, one of which, my C drive, is apparently my local drive. That has a drive type of 3. Let's actually filter this down then to only get those where the drive type property equals 3. Great, we get just that one. And really all I wanted to look at was the device ID, free space, and size. Well, we have a couple ways to do that. We learned about select object, and I could specify device ID, free space, and size. And that comes out as a nice table because, incidentally, PowerShell will always display things as a table if there are 4 or fewer properties. Since I only specified 3, and that's less than 4, I got a table. Another way I could have gotten that result, though, is to specify format table with the same list of properties. And the benefit here is that now I can specify the format table auto size parameter to get a little bit neater of a display. Here's the thing I'm not really crazy about, though. I hate having to count these. Is this 1, 2, 3, 4, 5, 6, 7, 8, 9? So that's 13 gigabytes against a size of... you know what? It's too complicated. I just want to see a display in gigabytes, preferably. Maybe megabytes is good for you. Well, here's how you can do a calculated column in a table. I'm going to display the device ID, but for my second column, I'm going to create something called a hash table. It starts with an @ sign, and it's contained in curly braces. In that hash table, I need to provide 2 pieces of information. The label that I want to use for the column, so in this case, I'm going to say the label is size, then a semicolon, and an expression that's going to be used to decide what is displayed in that column. That expression is a script block, so it goes inside curly braces. And inside those curly braces, I can use $_ to refer to the object that's being used on the current line of the table. I want to take its size property and divide it by 1 gigabyte. I'm going to do the same thing again for a second column. I'm going to give this one a label of free space and an expression equal to the current line's free space property divided by 1 megabyte in this case. When I hit enter, well, that's what I get. Unfortunately, because it did that division, it had a pretty big leftover amount, so the number's not necessarily a ton better than the one I had before, but it is easy to see that this is gigabytes and megabytes. Let's recall that line and modify it. We'll use a practice PowerShell uses for processes. Put an M there and a G here so that we know that's gigabytes and megabytes. So we just change the column labels. And now here's another trick. To get rid of that extra decimal, I'm going to wrap the actual calculation in parentheses and then tell PowerShell to display the default as an integer. So I'm using the -as operator to tell PowerShell I want to change the data type from a floating point with a decimal to an integer. And PowerShell knows how to convert those two numeric types, and it actually knows how to do rounding as well. So since this was 19.9, PowerShell rounded it up to 20 gigabytes. Since this was 12,882.4, PowerShell rounded it down to just 12,882. So you can really do some cool stuff with these custom columns, and you can have as many of them on the table as you want to. And the last thing we'll do is put that auto size parameter back in there to bring it down to a nice, reasonably sized table, fits in a small amount of space, and leaves us enough room on the screen that maybe there's some other properties we could specify if we wanted to. Format table really gives you the most flexibility and the most creative control for any of the formatting commandlets, and you're sure to find a ton of really useful purposes for it. In this nugget, we looked at how Windows PowerShell's formatting subsystem works. We started by talking about how objects become text with the out default commandlet and how they wind up in the console window with the out host commandlet. We talked about the formatting subsystem itself, how it works, why it makes the decisions it makes, and so forth. We looked at 3 commandlets that you can use to manipulate the format of what appears on the screen: format wide, format list, and format table. And we looked at advanced features of tables, including the ability to create custom columns that include calculated values. I hope this has been informative for you, and I'd like to thank you for viewing.